Welcome to the students in the new session. In the last lecture, we have discussed about integration and then some methods to find out the integrals of the various kinds of functions. So, as a recap of the last lecture, in the methods we have discussed few methods only. Method 1 was based on simply using the integration of the various functions by the standard or known formulas like x raised to the power n, e raised to the power x, a raised to the power x, 1 upon x. So, they are all those functions whose integrals are already known. So, if any function is of this type or resembles with any one of these functions, so we can very easily find out their integrals using these known formulas. Even then, there are certain functions which do not fall in the category of any one of the standard function whose integral cannot be evaluated by using these known formulas. Then what to do? Then we have used a new method which is known as the method by integration by method of substitution. So, substitution simply refers a variable given in the question, say x is being substituted or replaced by any new variable. So, this is another way out or another method to find out the integral of the various functions. After that, we have discussed one more method, that is of the type of what in which we are having a function which contains numerator as well as denominator. But the restriction was numerator is considered as the direct derivative of denominator. So, in such cases we get t is equals to denominator, then the function transforms to dt upon t and the integral of 1 upon t, log t. So, this is also a case of or a special case of method of substitution. So, after having discussed all these methods, we didn't talk about the functions multiplication. In all these methods, the functions whose integrals we are calculating, they are either added or subtracted. We may have two functions or even more than two functions, but they are always either added or subtracted. So, naturally, the next question is what if two functions are multiplied together, then how we can find out its derivative. So, if you recall the process of differentiation, in case of differentiation what we did, if two functions are being multiplied, then we can find out the derivative of such functions using the product rule. So, likewise here, if two functions are being multiplied together, then we can also find out the integral of this product of two functions using the method which is known as integration by parts, right. So, how this formula in fact runs or works, let us see. Whenever two functions are being multiplied, so the formula is written here. If say fx and gx, we have taken two functions, right. So, if two functions are multiplied means the integral of the product of two functions, this can be written as first function into integral of the second function minus integral sign within the integral sign derivative of the first function into integral of the second function into dx. This is the formula which we can use to find out the integral of all those functions which are multiplied together, right. In the next line, if you look at, we have also mentioned the formula mathematically. See, integral of fx into gx, fx, gx, they are the two different functions, they are being multiplied. Its integral is equals to, write down the function fx first function as it is. If you take fx as first function, gx as second function, right, write down the first function as it is into, write down the integral of the second function. So, fx into integral of gx dx minus under integral sign, derivative of the first function into again integral of second function, and this product is again multiplied by dx, right? So we can use this formula actually written here as the product of two functions can be simply integrated by using this formula. Now, before proceeding, the numerical questions are exercise based on this method of integration by parts. If you recall the process of differentiation, if two functions are being multiplied together, then we can find out their derivative by using the product rule. But in product rule, we don't have any restriction. We were completely free to choose any function as the first function, and naturally the remaining will be considered as the first function. But here we are not independent to choose any function as the first function and the rest is second. There is a reason behind this. So before proceeding or explaining that reason, what kind of function we will integrate, I have told you many times we will integrate only three kinds of functions because we have differentiated only three kinds of function. And you know, integration is simply the reverse or inverse process of differentiation. So therefore we will integrate only three kinds of functions: algebraic, exponential and logarithmic, right? So out of these three functions, what possibilities we can have? The possibilities we can have, say L for logarithmic, A for algebraic and E for exponential, right? These are the three functions only which we will integrate, right? So if you take any two in a particular situations, because we are dealing with the product of two functions, if any two are multiplied together, how many possibilities we will have? See, case 1 logarithmic is multiplied with algebraic, case 1, logarithmic is multiplied with exponential, case 2, and then algebraic is multiplied with exponential, case 3, right? These are three possibilities, and the remaining three possibilities, what happens there? If logarithmic is multiplied with logarithmic, the product will again a logarithmic function, so we will get a single function again. If an algebraic function is being multiplied with an algebraic function, the product will be again a single function. Likewise, if an exponential function is being multiplied with exponential function, then the product of two exponential functions is again an exponential function. So these three possibilities are ruled out. We need two different functions. So in terms of two different functions, we are having only these three possibilities. So throughout, we will encounter these three categories whose integral we will have to calculate by using the method of integration by parts. Now let us come to the point which function should be chosen as the first function and which function should be chosen as the second function. For that we have a convention. It's not a method. There is a very little bit difference between convention and method. Method is one which works almost in every conditions, but convention, it may work and sometimes it may fail. So be careful, it's only a convention to make our calculations easy, right? So the convention is written here: L for logarithmic, A for algebraic and E for exponential. The choice of the first function can be made according to the order of the letters of the word LAE. What does it mean? The order in which these three words are written, or these three letters are written, we should use the same order for the selection of first and second function. For example, if you look at these three letters, logarithmic functions are written first. So whenever two functions are being multiplied and one is logarithmic, we should always take logarithmic as first function, right? Here exponential is at the end, at the last. So whenever two functions are being multiplied and one is exponential, then exponential function should be taken as second. And what is the position of A, algebraic? If algebraic function is with logarithmic, it should be taken as second, and if algebraic function is with exponential, it should be taken as first, right? So what is the crux of this convention? The crux simply is whenever two functions are multiplied, if a function is logarithmic in the product, then the logarithmic function should be always taken as first. And whenever two functions are multiplied together and one function is exponential, then exponential function should always taken as second. And algebraic position changes. If it is with logarithmic, it should be taken as second, and if it is with exponential, it should be taken as first. And I hope this convention is very clear to you. And the reason for this convention is what? If you look at this formula here, the second portion of this formula is what? This one. If you look at this here, f dash x, derivative of the function into integral of gx dx and then dx. What does it mean? We have to integrate this function again because this portion lies inside the integral. So this convention is used because of the reason, if we will not use this convention, then this portion, second portion of this formula will become quite complicated or quite difficult. It would have been very difficult to find out its integral further. So what is the objective of this convention? The objective of this convention is to avoid such difficulty which we will encounter. To make our calculations simpler and easy, we will use this convention so that the second part of this formula should not create any kind of complications or problems in calculations or in finding out the integral further for the functions. We will use this convention. Hope this idea is very clear before you. So the choice of the first function can be made according to the order of the letters L, A, E, remark 1 and remark 2. Sometimes we have given only one function, right? We will see in the examples further. Sometimes only one function is given to you and you have to find out its integral. So what we will do, we will multiply that function with 1, right? 1 into the given function, we will consider it as a product of two functions, and then we will use the formula of integration by parts, right? So students, let us proceed for some numerical questions based on method of integration by parts. So here look at case 1, evaluate the integral x log x dx. In case 1, what is given here before finding out its integral? Here we are having two functions x log x, right? And we have to find out the integral of this product. And what we did here, x is known as algebraic, right? This is algebraic function, and log x is logarithmic function, right? So which function should be taken as first and which function should be taken as second, this we have to decide. And we just discussed in the last slide the basic convention which we will have to follow for the selection of first and second function. So what was the convention? In convention, what we have seen, the logarithmic functions are always taken as first, right? Logarithmic functions are always taken as first, and exponential functions are always taken as second. The position of algebraic function lies in between these two, right? So here we have the product of two functions, one is algebraic and other is logarithmic. So by the convention what we have discussed, it allows us to choose log x as the first function, right? And naturally x will be considered as second function. So we take here this log x as first and this x as second function. Clear? Students, I will advise you, don't write first and second whenever you are writing down the solution of these questions. I am writing here only for your understanding because this is the first exercise. That's why I am trying to mention each and everything very clearly so that you can understand the basic concept, how we can use the method of integration by parts to find out the integrals of the various functions if they are multiplied together. So you are requested or you are advised, don't write first and second in your answer sheets whenever you are writing, right? So here log x is taken as first function and x is taken as second function. Now we will use the method of integration by parts, which simply refers what the first function as it is into integral of the second function minus integral sign derivative of the first function into again integral of the second function with dx. See, log x is taken as first function. So log x is written as it is, right? Log x as it is. See, this is equals to log x first function as it is into integral of second. So integral of second means integral of x dx, right? Because x is considered as second function minus use the integral sign derivative of the first function, so d over dx of log x, right? Because log x is taken as first function into again integral of second function, that is x dx, and enclose these terms in a bracket and dx should be taken outside the bracket. So this is what we obtain here in this line. This line we used only the method of integration by parts. Now write down their proper integrals to get the required integral. See, log x will remain as it is, no change, and integral of x, you know by the formula of x raised to the power n, that is what? That is x square by 2, clear? Minus integral sign again. Derivative of log x is what? Derivative of log x we know 1 upon x, right? Derivative of log x is 1 upon x into integral of x is again x square by 2 dx, right? We are getting this line, clear? Look at this. Integral log x will remain as it is, integral of x is x square by 2 minus under integral sign derivative of log x is 1 upon x, and again integral of x is x square by 2 into dx. So what is left here? 1x will cancel out with here, you will get here x square by 2 of log x minus plus k, you can add here, no problem, or c, not k, take a constant c. We are taking c throughout, so we will take here c also. What is left here? Here we left x dx, and this 2 we can write it outside, right? So 1 upon 2 of this, clear? And this is what? X square by 2 times of log x minus 1 upon 2, and integral of x is what? Integral of x is again x square by 2 plus c. Now simplify it. This is x square by 2 of log x minus x square by 2 into 2, 4 plus c, right? This is the required integral, and finally you will get this line, and here we have taken x square by 2 common, so what you will get? Log x x square by 2 if you take common, you will get here log x minus, here you will get 1 upon 2 and plus a constant c is there, right? So this is how we can use the method of integration by parts to find out the integral of the functions whenever they have multiplied together. Simple process. We are not going to use any new integral or any new formula, only the way or the approach for writing down the solution of any question has been somehow changed, right? Similarly, you can also find out the integral of the second function. Here what is given you? Here we have given only one function, that is log of x. So we have to find out the integral of log x. I have told you when we have started the process of integration, integral of log x we have not yet discussed. Now we will find out the integral of log x. So here we are having single function, that is log x dx, right? And if you remember, I have also told you whenever we have a single function, then we can multiply that single function by 1 to make them the product of two functions. So here we will multiply this log x with 1. So what is this? Log x into 1, right? Clear? Here we are having the product of two functions log x into 1. And you know log x are always considered as first function. So we will take this log x as first and this 1 as second function. Clear? And now you can use the method of integration by parts as usual as we used in the last example. See, log x will remain as it is, right? This is equals to what? First function as it is, right? Into integral of the second function. So integral of the second means 1 dx minus integral sign derivative of the first function. Derivative of the first function means derivative of log x, right? Into integral of 1 dx again, and then this should be enclosed in a bracket and dx should be written outside this. So we did this line. Look at this line. Log x as it is, integral of 1 dx minus integral sign derivative of log x into again integral of 1 dx, because 1 is considered as second function and dx is written outside. Now simplify it. Log x will remain as it is. This is equals to what? Log x will remain as it is, and integral of 1 is what? Integral of 1 is naturally x, because derivative of x is 1. Minus, use the integral sign. Derivative of log x is 1 upon x, and again integral of dx is x and then dx. So this x and x will cancel out. What is left? This is equals to x log x minus x log x minus what we get here dx plus a constant c, right? And this is what? This is equals to x log x minus integral of dx is what? Again x plus c. Take x common for your convenience. You will get here log x minus 1 plus c. So this is the required integral what you obtained by integrating a single function log x by using the approach. In some cases we will use this approach. A single function is given to you. So what we will do, we will multiply that single function by 1 simply, right? And if the single function is multiplied by 1, then we will consider this as the product of two functions, means the function itself and the 1, and then choose the first and second function as per the convention that we have already discussed, right? So this is how we can find out the integral of the various functions using the method of integration by parts. Second thing is what? One more thing I will also advise you. As far as the constant of integration is concerned, it's not mandatory for you, you should write down the constant of integration in every line. I will advise you, it's far better, you should add the constant of integration in the last line. Whenever you are writing down the final integral of any given function, use a constant of integration. It's also true. However, you can also use the constant of integration in every line. Anyhow, if you forget, then you can add the constant of integration whenever you are writing down the final integral of the given function. If you will not add the constant of integration in the final integral, your integral will not be considered as correct. After this, we can have, actually this was the method of integration by parts. Now this is also a special case of the same method. That is, if the function is given like this, e raised to power x fx plus f dash x dx. What does it mean? See, if you have a function of this type, fx plus f dash x and dx, what does it mean? The first function and this is second function. So what is the relationship whenever the second function given in the question is the direct derivative of the first function, and this sum is multiplied by e raised to the power x. So whenever you have any function which resembles this function or which is of this type, then its integral is always equals to e raised to the power x fx plus a constant, means e raised to the power x into first function. Are you getting the point? What does it mean? So whenever you have any function which is of this type, you can write down its integral by using this formula. Now there are two possibilities again in this situation. There are some functions which looks very much similar to the given function directly. You can use this formula to find out the integrals of those functions. But the situation is not always so simple. On the other hand, there are some functions which never assembles like this function, but after having a sort of manipulations, you can transform that function to this form. Even then you can use the same formula to find out the integral of all those functions. See, how does it work? This type of integral can very easily calculated like this. See, the function is given like this: e raised to the power x fx plus f dash x dx. First break up the given function in two parts. So this can be written as e raised to the power x fx dx first part plus e raised to the power x f dash x dx second part, right? We have not done anything now. We are only separating. This is the first part, this is the second part. Now we know that from here the second part is the direct derivative of the first part. This we have already observed. So what we will do, see, this is the product of two functions ex into fx. E raised to the power x is exponential function and fx will be either logarithmic or algebraic. So two functions are being multiplied here, we will use the product rule. And again here two functions are being multiplied, but what we will do here, the beauty of this method is what? Since f dash x is the direct derivative of fx, therefore we will keep the second portion as it is, unchanged, but we will use the method of integration by parts only in first case. See why? Using integration by parts in the first part of the integral, see mentioned here, second part will remain as it is, unchanged. See, fx is taken as, exponential functions are always taken as second, so this is taken as first function and this should be taken as second function, right? So first function means fx, integral of the second function is there, minus derivative of fx is there into integral of second function is there, and dx is this, plus this function as it is. We are writing down this function unchanged, right? Now write down the integrals. E raised to the power x fx, because the integral of ex will remain ex, so we will get here e raised to the power x fx minus derivative of fx, f dash x, and integral of ex, ex. So what you will get, e raised to the power x f dash x into dx plus a constant minus this e raised to the power x f dash x dx is already there. So this and this will be cancels out. What is left? E raised to the power x fx plus c as a constant. Do you understand why we don't use the method of integration by parts in the second portion? Because when we will use the method of integration by parts in the first portion, so one part of this formula will be similar to the function e raised to the power x f dash x. That is why they cancels out, right? So whenever we have any function of this type, we can use this technique to find out the integral of the various kinds of function. Let us take an example to understand. Evaluate the following integral: e raised to the power x 1 upon x square minus 1 upon x cube. Sorry, this is 1 upon x square minus this is 2 upon x cube, right? Change it. So see, we don't have any option. Actually, how we will understand we should use this method? This is also a problem. See, the given integral is e raised to power x, the given function is e raised to power x 1 upon x square minus 2 upon x cube. What methods we have studied? We cannot use the direct formula, we cannot use the substitution here. However, we can use the integration by parts, but this is also the case of integration by parts. But if we will use here integration by parts, the calculation will become very lengthy. Actually, the objective of finding out the solution of the problem is not more than sufficient. Rather, our objective is also the calculation should be simpler and easy so that the students feel comfortable in solving out the problems based on a specific method. So look at this example. If we will use integration by parts here, e raised to power x as a first function, our second function, and 1 upon x square minus 2 upon x cube being algebraic should be taken as first function, you will get the answer, but the calculations are very difficult. So what we will do, we know this is the only way out which we can use. The reason is that it also contains e raised to power x. Look at here, the function contains e raised to power x, it also contains e raised to power x. Second thing is what? 1 upon x square, its derivative is what? See, x minus 2, you can transform this. This is equals to what? What is its derivative? This is minus 2 x power minus 3. So this is minus 2 upon x power 3. So see here, 1 upon x square and minus 2 upon x power 3. So 2 upon x power 3 is the direct derivative of 1 upon x square. So this is very much similar to the function of the type e raised to power x fx plus f dash x. So we can use it here. See how we will solve it. E raised to power x 1 upon x square minus 2 upon x cube. This is our original function. So what we will do, we have seen just earlier. First we will write down in two parts, and their two parts are e raised to power x 1 upon x square into dx. This is our first part and this is our second part, right? We haven't do anything now. Now the function has been divided in two parts, and you know what the method refers to? Keep the second part as it is, unchanged. So this part will remain unchanged. What we will do? We will use the method of integration by parts in the first portion only, means this one. So come on and use this method of integration. E raised to power x into 1 upon x square. E raised to power x is an exponential function. It should be taken as second. So 1 upon x square being algebraic should be taken as first function. So 1 upon x square e raised to power x into 1 upon x square. This is our function. This should be taken as first and this should be taken as second. Now use the formula of integration by parts. First function is 1 upon x square. So 1 upon x square as it is, right? Into integral of the second function. See, integral of e raised to power x dx we have written, minus derivative of the first function. First function is 1 upon x square. So d over dx of 1 upon x square. This we have mentioned. Into integral of the second function again multiplied by dx, minus the second term will remain as it is, 2 e raised to power x divided by x cube into dx, plus a constant c is always added. Now the integral of e raised to power x will remain e raised to power x. So what we will get here? E raised to power x divided by x square, right? Minus derivative of 1 upon x square. If you calculate the derivative of 1 upon x square is minus 2 upon x cube. You know this. So this is minus 2 upon x cube, and integral of e raised to power x will remain e raised to power x, right? And this is dx. Now the second term will remain as it is, 2 e raised to power x cube plus the constant. Again this and this will be cancels out. What is left? E raised to power x upon x square plus c. This is your required constant, integral of the given function. So what does it mean? Yani the integral of the function of the type e raised to power x fx plus f dash x dx is equals to e raised to the power x into first function. See, here the first function is what? E raised to the power x, and the first function is 1 upon x square. So its integral should be e raised to the power x upon x square plus c. Hence, you know, we are getting the same function, right? Now, see, this is also a very good question based on the similar pattern. Evaluate the following integral: x e raised to the power x upon 1 plus x raised to the power 2. See, the function is x e raised to the power x divided by x plus 1 and its power 2 dx. Now, see, we don't have any direct formula to find out the integral of this function, and since it contains e raised to the power x, so we can think or we can guess this function may also transform to the function of this type ex fx plus f dash x. We are only guessing, we are not sure, right? I have told you just now there are some functions which looks very much similar to the given function directly, as we did in the last example. In other cases, there are certain functions which will be transformed to this type after sort of management or manipulations. So this is a case 2 category. So see here, x e raised to the power x divided by x plus 1 raised to the power 2. Here we contains e raised to the power x. See, this is e raised to the power x. X divided by x plus 1 its power 2. This is dx. So we don't have any way out. So since it contains e raised to the power x, so we can guess that it can be transformed to the function of the type of e raised to the power x fx plus f dash x. Right? Let us try whether we will succeed or not. See what we can do here, e raised to the power x. In denominator we contains x plus 1. So what we can do, we can add 1 and subtract 1 in numerator, right? We can add 1 and then subtract 1 in numerator, it's no issue. Is dr is 1 upon x plus 1 raised to the power 2, right? Okay, no problem. Step 1. This is what we did here. Now we can separate this numerator in two parts. One part this and the second part is this. So this can be written as c e raised to the power x, x plus 1 divided by x plus 1 its power 2, right? Dx, separate them. And second is e raised to the power x, what is left? Minus 1 upon x plus 1 its power 2 and dx, right? This means this step. Now x plus 1 will be cancelled out with x plus 1 power. So what we will get here, e raised to the power x divided by x plus 1 dx minus, it will remain as it is, e raised to the power x, x plus 1 power 2 dx, right? So we reached here, right? No problem. Now what would happen this, see 1 upon x plus 1, its derivative is what? If you calculate its derivative, it will come out to be minus 1 upon x plus 1 raised to the power 2. So see here we are having 1 upon x plus 1 and here we are having 1 upon x plus 1 raised to the power 2. So the second function is the direct derivative of the first function. It means this function can be written as like this. See, I am showing you, if you take e raised to the power x common, what will be left? See, 1 upon x plus 1 minus 1 upon x plus 1 power 2 and dx. See, this is your f x and this is your f dash x, right? 1 upon x plus 1 and its derivative is minus 1 upon x plus 1 square. So this is of this type. So what we will do, we will keep the second portion as it is unchanged and we will use the method of integration by parts in the first portion, that is e raised to the power x upon x plus 1, and e raised to the power x is an is an exponential function, so it should be taken as second. 1 upon x plus 1 should be taken as the first function. So see the formula, the first function 1 upon x plus 1 as it is into integral of the second function e raised to power x dx minus derivative of the first function, that is derivative of 1 upon 1 plus x into integral of the second function plus a constant, and this second function will remain as it is. So integral of e raised to the power x will remain e raised to the power x. What we will get? E raised to the power x upon x plus 1, this minus, and derivative of 1 upon 1 plus x is minus 1 upon 1 plus x power 2. So this is minus 1 upon x plus 1 power 2. Integral of ex is ex dx plus c minus this is as it is, right? So c e raised to the power x 1 upon x minus minus you will get here plus e raised to the power x 1 plus x square dx plus c minus e raised to the power x 1 plus x square dx. So this will be cancels out. What is left? E raised to the power x 1 plus x plus c is the required integral of the given function. I think students we should stop it here and we will continue the remaining portion in the next lecture, right? Okay.